Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we will discuss about flood fill algorithm. So this is completely based on a recursion concept. Our explanation here is completely based on the assumption that you already have some basic coding knowledge. If you are not good at basic coding, please visit our website learningmonkey.in. Take the course placement training for service-based companies, then come for the competitive coding. Coming to today's class, let's understand the question. An image is represented by a two-dimensional array of integers. Image is represented in a two-dimensional array of integers. Values given in array are pixel values. They are going to give you the pixel values in the array. Our task is to flood fill that. So what's that flood fill? Let's try to understand. Given the coordinate, so they are going to give you coordinates, means row value and column value for the starting pixel. For the starting pixel, they are going to provide you the row value and the column value and a new pixel color. So inputs are a row value, column value, and a new pixel color is going to be provided. So flood fill means here what we need to do here is take the starting pixel color, whatever the starting pixel color is, convert the pixel to the new color, whatever the new color they have provided, convert that color, the starting pixel color into new color. Not only that, from starting pixel, take the pixel 1 up, means take the up position, down position, left position and right position. If any of the 4 pixels have the same color as starting pixel color, then convert that also. Keeps on going like that. That is what convert that into new color. Continue the process to change the possible pixels. Anyhow, with example we are going to understand it better. Let's take an example. This is a two-dimensional array, 0 1 2 3 4, n lines and m columns are there. So assume that the starting pixel is 4 comma 1, means 4th line, first column. This is the starting pixel. What is the color of the starting pixel? It is 1. What is the new color? 2. So 1, here you have to place it as 2. One step left, 0 is there, so don't change. One step up, 1 is there, so change it to 2. One step right, 1 is there, change it to 2. One step down, 1 is there, change it to 2. Similarly, from here onwards, left, up, right, down. Keeps on going like that. Here onwards, up, left, right, down. Wherever you found 1, change it to 2. That is what you have to do it. So after converting this input into this output, this is how we are going to get. See, all ones are converted into 2s except this one and this one. Remaining all are converted. So this is what the output is. Now coming to the logic part, and here they have provided the time complexity of, you have to maintain a time complexity of order of n by m or space complexity of order of n plus m. So for in order to, they are going to provide you the starting pixel coordinates x and y. So we are assuming it as x and y, you can take it as s, c, s or like that, different values. So from there onwards we are going with a recursion concept. So we are going to explain you the logic of both recursion concept and without using recursive functions also you can do it. We will discuss both the logics, but in the coding part we are going to provide you with the recursive function logic. Coming to the logic part, using recursion, assume that this is our first pixel, starting pixel. See, row number and column number has been provided. These are provided as f of x comma y. If you take those values in a function x comma y, so this function is calling the first pixel value, the starting pixel value. Each function is going to call 4 different functions. So from here onwards we are going to call this one up, right, down. How we are going to call? X comma y is the coordinate of the starting pixel. X minus 1 comma y is the pixel of up, the coordinate that belongs to, that 1 belongs to up. Similarly down, if you want to call the down value x plus 1 comma y is the coordinate that belongs to the down pixel. Similarly, left pixel, if you want to do that, x comma y minus 1, it is going to give you the left pixel. Similarly, right pixel. So each function is going to call 4 different functions. One function is going to call up, down, left and right. And in our previous classes also we have done many examples on recursion. Whenever we consider recursion concept, we need to identify the condition when to stop. See here, if you start from here, if you go with the left one is 0. It is not the starting position pixel value. If it is 1, then only continue. Change it to 2 and continue calling left, up, down and right. So if it is not 1, no need to extend. That is one of the condition to stop the function calling. Not only that, if you take this function is going to call this pixel value, and this pixel value function is going to call left one, and this left one is going to call this left one. So whenever we are moving away from the pixel values, we can stop it. Means x should not be 0, less than 0, y should not be less than 0. Similarly, x means number of lines. If it is n by m matrix, a number of lines should not cross beyond n. Number of columns should not cross beyond m. These are the conditions to stop. Means we are moving away from the matrix. So these are the conditions we are using to stop the recursive function call. So now coming to the next, without using recursive functions, how we can do that? Take the first pixel coordinates and push onto the queue. We are going to use a queue data structure. The first pixel coordinates are pushed onto the queue. Pop the elements from the queue, means the first pixel coordinates will come. Check the up one. If it is 1, push onto the queue. The coordinates are pushed onto the queue. Check the left one. If it is 1, push those coordinates onto the queue. It is not 1, so don't push it. So check the one down. If it is 1, push onto the queue. Check the pixel on the right. If it is 1, push onto the queue. Then convert this into 2. Similarly, now take the next coordinates from the queue. Which one you are going to get? This one. Same process, repeat, push onto the queue. So pop the coordinates from the queue and add the left, right and up, down and down coordinates to the queue. This should be repeated until queue is empty. This should be repeated. Pop from queue until queue is empty. Similar questions we have done in our previous examples also. This is very, very simple. So these type of questions we discussed in our basic examples, basic placement course also. That's why we are not giving much explanation on these concepts. Hope you understand. We are going to show you the coding part also. But our suggestion is, after listening to the logic, you try to solve it on your own. See, these are the conditions to stop. If ij means the starting pixel coordinates, xy coordinates. Here it is considered as ij, new color value. So I less than 0, I greater than or equal to m, or j less than 0 or j greater than or equal to n, or image of ij not equal to starting color, or image of ij equal to new color. If anything happens, just return. Otherwise, you convert that image of ij into new color, then call the 4 functions. These are the values for 4 functions. This is the example which we considered here. Hope you understand this example. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.